A stalactite has the shape of a circular cone. Its height is 200 mm and is increasing at a rate of 3 mm per century. Its base radius is 40 mm and is decreasing at a rate of 0.5 mm per century. Determine if its volume is increasing or decreasing and the rate at which the volume is changing. So, since it's about the volume of a circular cone, we can consider a formula for the volume of a circular cone, which is 1/3 area over base, which is pi radius squared, and multiplied by the height. Notice that radius is a function of time and the height is also a function of time. And we can differentiate both sides to get dv dt is equal to, we can see a product of two functions on the right hand side, so we should apply a product rule. So it becomes 1/3 pi. It's a constant, we can factor out it, and a product rule says that it should be the derivative of the first function. Derivative of r squared is 2r dr dt according to the chain rule, and multiplied by just the second function h plus just the first function r squared multiplied by the derivative of the second, so it's multiplied by dh dt. And now let's substitute values. So it is equal to, or it would be better to write when h is 200 millimeters and dh dt is plus 3 millimeters, because it is increasing, so it's 3 millimeters per century, and r is 40 millimeters and dr dt is negative 0.5 millimeters per century, and then dv dt is equal to 1/3 pi 2r, it's 2 times 40 dr dt, it's negative 0.5 times 200 plus r squared 40 squared multiplied by dh dt, it's multiplied by 3, so it is equal to 1/3 pi, it's negative 8,000 plus 4,800, which is finally negative 3,200 pi over 3, which is approximately negative 3,350 to three significant figures, and unit is, since it's the rate of change of the volume, so it should be millimeters cubed per century, -1. And that's all for this question.